Welcome everyone to session 7. For this session, I'll be talking about a few notes to start off with. There are a number of questions about applying external formats from a published data set. So we'll look at how to apply external formats using a SAS program and a formats catalog. So I have a VM spun up here with SAS, and I'm going to be using this to show you the examples. So first thing I'm going to do is set my libname up here. So do libname statement, and I will run the libname here. Now let's look at the files in the datasets folder. A couple of these files are SAS programs. One of them includes a formats proc. So at the top you will see proc format, and this we can run in its entirety to save the formats to our work library. So this will create the actual formats, and the way we would apply them here is if we look at the second file called format statement, CHS 2011 public. This is a formats statement, and we can use this format statement within a data step to apply the formats. So first thing I'm going to do is I will load the data set, CHS 2011, set from lion, CHS 2011 underscore public, and I will check to see if that matches. It does. And what I can do is so load all formats from the SAS from program. So we can do that by doing an include statement here and giving it the path of the actual file. So I know it's in this datasets folder, so I'm going to put that in the front, and then I'm going to call it the name of the file. So CHS 2011 public. Remember it's .sas, and then we run that. So once I run that, it will find that document and run it automatically in the background. And if I go into my work library, I will see that all of my formats have been run. So I'm basically running this whole thing without having to highlight and run. So I'm running it within another program. So this include statement allows me to source another SAS program from in a different folder, potentially. So we can do that, and then once we do run the data step, it'll take a little bit since I am using the virtual desktop, and this goes through the internet, so all of my data gets read in through the internet. So sometimes it's better to have a working library that's local and use that instead of, so you only have to read from your actual computer once. So now this data set in the working library is loaded in. So I can do, so notice I didn't get any format errors. If I check my log, everything looks okay. When I source this file, you get notes saying that the format has been output. And when you load the data, you have everything that looks okay. So we can do a proc print of data equals CHS 2011, OBS equals 20. So we run that just to have a look at the data that we have, and we see that our data looks okay with the formats applied. We see yeses and nos and those value labels that are informative. So that is enough to load the formats from this formats underscore CHS underscore republic program. But what we can do as well is use a catalog to load the formats. So notice that I didn't use the format statement here, that second file that was provided, and that's because the formats were already applied to the data. So I didn't have to apply them myself. So when you do a proc contents of that data set, you'll see that every variable has a format attached to it. And that happened when the CHS folks created this data set. They had already applied these formats to the variables. So when you try to read these in, SAS will go looking for the formats, and if they're not in the work library or any other location where you tell SAS to look for them, it will give you an error. So that's why sourcing the formats first and then running the data works just fine. But if my data, the data that I had gotten were raw without any formats attached, I'd have to run this in a data step, and I'd do like something like data, my data set, my lib name, and then CHS 2011 to apply these formats as usual with a format statement, the name of the variable and the format name, and then run it. So that would be the alternative way to load or apply formats to the actual data within a data step. So remember, whenever we use a data step, we're modifying the data, and if I use this format statement, I can apply the formats to the data. So the other way to do is to load a format using the um, catalogs. So when we save a catalog, these are portable, and so currently we have a formats catalog here. It's very generic. It's in the work library and it's called formats. So we can save that into a external file rather than having it in our work library. And I'll show you how to do that in a second. So in order to save our formats, we have to run this proc formats, and give it a option. There's a library option within the proc format statement where you can give it a location where to save your formats catalog. So I will call it here in the proc format statement. I can add this library option equals libref. I've created this libref already, and it points to my datasets folder, so I can create this catalog called my catalog when I run this proc. Remember that when you can also collapse a bit of code and run the entire thing. So in this case, I can collapse it so I don't have to drag all the way to the bottom, and then I run my proc. So that will create or generate a data set, or I mean a catalog here, and you'll see that if I browse to my folder, um, it will have created a catalog, and it's currently still adding formats to that catalog. So you have to wait a little bit before you can start using it. But right now, you'll see that this file is created, and it's being updated with all those formats. So when it finishes, you'll see that it'll give you a real-time process time here at the bottom, and it will save all of those formats into that my catalog file. So now I have this my catalog um, file in my data sets. So if I were to come back in to SAS, so I'm going to say new session here so that I can distinguish. Um, for those of you watching, make believe that I closed SAS and reopened it, and now I'm in a fresh session. So the first thing I always do is create a lib name, right? And then I will tell it to look for my formats in a particular location. So if you remember from session 4, we have this global option called options format search, and we give it the actual location of that our formats file. So let's do that. So I'm going to use options fmt search parentheses lion my catalog and then the work. So I go back. So we say format search equals and the two locations for the catalogs. Format search equals and the two locations for the catalog. So if you don't include that equal sign, you'll see that the format search word doesn't light up until you add the equal sign. So that's a good help for using the enhance editor here. So I can run this, and because I have a catalog already in this location, I will, to further show you that it will look into that catalog, I can delete my current formats in the work library and run this part here, the data step, and now SAS will know where to look for the catalog using this format search location. So now I'm going to recreate this CHS 2011 data set. And it will take a little bit because it is, again, reading from my local machine to the CUNY remote desktop. So the amount of takes depends on the connection of the connection to the CUNY servers. All right, so it finished loading my data set, and it didn't give me any issues with the formats because it knew where to look for them in the lion.mycatalog location and in the work. If it had not found anything in the any particular format in the lion.mycatalog, it would have resorted to the work location, and currently the work location does not include any formats, so it must find all of the formats in that first location. Alright, so that was the second way that you can load your data that has formats attached to it, and using a catalog. Sometimes it's provided by the people who publish the data set. They provide either a catalog or a program. You now know both strategies on how to load that format. So the outline for today is we'll be talking about proc sort and proc transpose and working with merging data sets from different sources. So you can pause the video and look at these warm-up exercise and do them without looking at your notes so that you have some familiarity with the SAS software already, so you should be able to run this without looking at your notes. Okay, so first we set our lib name statement using the ref libref in this case, and then we load the data set. So we call it new and set the data from the ref, libref, and the class CS dataset. Then we do a proc print to have a look at the data. Then we can sort the data by borough because we're running a means by borough. So we sort by the borough variable first, and then we run the proc means with the appropriate statistics that we want to get from that procedure. And then finally, we can run a proc freak on the data set with the interaction of two variables, in this case gender and borough. So we'll see how both variables relate to each other in the crosstab. So we can do proc sort to remove duplicate observations, and we have a number of options in the proc to achieve this. So no dup here removes duplicates on all of the variables. Dup key removes duplicates on certain by variables, and dup out lets us save the data set into a new data set without the duplicates. So in this case, we're creating another temporary data set called my version 1, setting it from the class DS permanent data set, and we're doing proc sort data equals temporary data set no dup, so removes duplicates on all variables, and then dup out. So we can set this new dup's data set to the new data set that does not include any duplicates, and then we give it a by statement by gender, descending, and by borough. Another proc to be familiar with is the proc transpose, and that allows us to reshape our data from either a wide or a long format. So in this case, we want to give it a data option with the name of the old data set, and an out option with the name of the new data set. And once you start using SAS more often, you'll see that this out option can be added to many of the procs that we use to create new data from the proc. And then you can add some by variables to transpose by a certain variable, and then ID variables to identify what variables are the ID or patient ID variables, and VAR is the variables that we want to collapse. So this will make more sense once we start working with it and showing you an example. So we use the by statement if there are any variables we want to keep as variables, and variables in the by statement are included in a new data set but are not transposed. So then the transposed data set will have one observation for each by level per variable transposed. And the data set must be sorted, of course, by that by variable before you transpose. And the ID statement will contain variables whose values will become the new variable names. So the VAR statement is the values that are throughout the data, and those will be important when you are reshaping the data. So let's look at this proc transpose here example, and we're going to use the transpose data set in our folders. So we'll pull up my VM here and run this transpose data. Should be in your folders, if not it's on GitHub. So here we're going to add comments, and then we're going to say data baseball set lion transpose data run. So we'll run that. Once that's loaded in, we can have a look at the data by doing proc print data equals baseball. So you'll see that this data set contains a long type of data set here, where we have the observations down the rows here. So we have 8 rows for 2 teams and 4 players. So if we want to transpose this so that we have 1 player per row, we can use the proc transpose method. So we have data for the type of value here, so salary or batting average, and entry here for the value in those 2 types. So then we can do proc transpose here. I can copy this. So we're transposing proc transpose. Our old data set is the baseball, and then out is the data set we'll call flip. And we want to transpose by team and player. So those are the variables that we want to keep. The ID or ID statement will identify type as our variable. And finally, we have VAR, which identifies that numeric value variable in the data. So we'll run that, check our Explorer. We see that a flip dataset has been created. And we can do proc print data equals flip, run. So now that so I tried to run this without sorting first, and remember that sorting is important. So if you don't sort, you'll get an error. So let's sort first. So sort the baseball data set by team and player, and then we run that. And now we run that again and run the flip data set. So now you'll see that those observations in team and player that were unique are collapsed. So you'll have Garlic's 10 and Garlic's 21 for 2 rows, and then the Peaches player with the number 8 and number 10 in their own row. And now you'll have a salary column, which was the type that we used, and the batting average column as the other column. So you'll see that there's this name variable that identifies the name of the variable that was used to create those columns. Alright, so that is how we transpose from long to wide. And you can play around with it and do the opposite operation and transpose that from wide to a long data set. But for now, let's look at combining data sets into one data set. So we can concatenate data sets, and usually you'll have survey data sets that are of the same, have the same rows or the same columns, and you're able to concatenate these quite easily. So in this case, we're adding or stacking data sets um, when we pass these two data sets to the set statement. So the set statement doesn't only can not doesn't only accept one data set, but you can add multiple data sets in the set statement. So it'll add observations in the first data set and then observations in the second data set. So it's sort of a stacking method here where the columns have to match in the two data sets. So in this case, we see that we have two data sets with two variables each, and one data set has the var1 data or variable and var2, and the second data set has var2 and var3. So when you do a set statement with those two data sets, you will collapse or stack them on top of each other, and any variables that are not present in the other will get a missing value for those observations, and the same in both here where you see var1 and var3 have missing data. If the two variables that you are joining don't have the same type, you'll get an error message. And we are familiar what types are in SAS. So if it's not numeric, if one variable is numeric and the other is character, if you try to join those, that will give you an error because you can't mix types in SAS. So here's an example. So in this case, you combine these two data sets. One has var1, var2. This one has var2 and var3. So var2 in this case, in both data sets, is of a different type. So in the first data set, it's numeric. In the second data set it's character. So you'll get an error when trying to combine those two data sets. You can also do a match merge in SAS, and this is using the merge statement provided with a by statement. So here you're using a data step, creating the new temporary data set from these two data sets. So you're merging those two data sets by a particular variable. So remember that whenever you use a by statement, you have to sort the data first. So here we see how the matching occurs. In the first data set, you can have multiple IDs or multiple measurements, and it will match for those IDs in the second data set. So you see how one matches with one, two against both of the two observations in data set 2, and so on. If the non-by variables have the same name, these can cause an issue. Or if you forget your by statement and forget to sort, or if the by variables do not have the same name. So then you have to rename your by variables so that they both match in both data sets. So let's look at the first instance where non-by variables with the same name. So if you have the same name in both data sets and you're merging by ID, one will get replaced. So in this case, we have data set 1 where we have var1 and var2, and in data set 2 we have var2 and var3. So notice that we have var2 in both data sets. So when we merge data set 1 and data set 2, var2 will supersede whatever was in var2 in the first data set. So you have to be careful when merging this way and ensure that all your variables have distinct names. So another error you can come across is that non-bivariables with the same name, if they don't have the same type, you get an error message. So remember that SAS doesn't like type mixing, so you'll always get an error when that occurs. So as I said earlier, if you have bivariables that don't have the same name, you can avoid that issue by renaming the variables in that data set. So in that previous example, we saw that we have var2 in both data sets. We can rename var2 in data set 2 to a different name so that we have the complete data. And of course, we can include this in the merge statement with the rename equals old name, new name as part of the rename. You can also run into issues where if you forget the by statement, you'll just have one ID variable superseding the other ID variable. So in this case, DS1 gets taken over by DS2 if you merge them without using the by ID statement. So you have to be careful there. And if bivariables do not have the same name, we can always rename them so that we can use them to merge, and then remember to keep these variables sorted. And as we looked at previously, we can convert variables between character and numeric whenever we have issues when merging. So we use the input and put functions to go from one variable or data type to the other. So from numeric to character, we use put. From character to numeric, we use input function. The retain statement allows us to keep a value instead of using default value that SAS uses whenever it loops over any calculation. The retain statement allows us to keep the previous value, and add more to that. And that can be really useful when we're working with running sums. And here I have an example here where we load or create a data profits data set. And we have two variables, month and profit. And so we run this, and we have a look at the data here. So proc print data equals profits, run. So we have a number here for each month, and if we were to just use run this data step to create a cumulative profit variable without the retain statement, we'll see what happens. And we print this out here. So here I'm just taking the sum of the profit variable, and adding cumulative profit to that. So this will iterate over every row, And because SAS resets at every iteration to a missing value, you'll get the same number for each observation. So let's have a look at what that did here. So here we have profit, and then we have cumulative profit. So you'll see that at the first iteration, it'll give you the sum of profit and cumulative profit. And when it started out, it was missing, so that it just gives you 12,451. And then at the next iteration here, it'll give you the sum of profit and cumulative profit. So if that were missing again, it'll give you the same number, and so on and so forth. But when you add the retain statement, SAS will keep it in memory when you're running this iterative function here to sum profit and the last value of cumulative profit. So let's run that here and have a look at the data set here. So I'll do a proc print data equals. So when you run that, SAS knows to keep the last value of cumulative profit. So in the first iteration, it'll say sum of profit plus the missing value, and that is 1245. And then it will come around to the second observation and do sum of profit plus the last value of cumulative profit, which will now work and say 66776. So you'll see how important that retain statement is, so that SAS knows to keep a track of a particular value when it's looping through the rows here of this data set. So you'll have a cumulative profit column with total number of profits in the last row here. So that wraps up our SAS lesson for this week, and stay tuned on Blackboard for the following Session 8 material. Thanks for watching.